Alright, so we're going to go over measuring angles in your little system here, Cartesian coordinate plane. The way that you're going to learn this in trig is going to be completely different than how it is in physics. So just learn the physics way now. Just get that into your memory, especially if you're having troubles remembering it. And then once trig comes, be prepared to, forget all of it because you're going to learn something else. Physics is interesting. Okay, so we're going to go to example 6.2. We have our plant that's hanging two strings like this. This is 30 degrees. And then this right here is 40 degrees. And of course we have our little plant thing or whatever down here. We're only looking at the angles, so I can zoom in a bit. So 30, 40. In physics, we have our x and then our y up here. So y is up and down, x is across. So we always measure our angles from x and we just go around like this to find the correct angle. So we go, counterclockwise. So this right here, 30 degrees, that's correct because we go from right here on the x-plane up to the line, and that's 30 degrees. And then to find this angle, right here, we're going to go to this line, but we're going to start all the way down here, go over, stop right here. Each of these squares right here makes a right angle. As you know, a right angle looks like that, 90 degrees. So we have 90 for this quadrant, and then we have another 90 for this quadrant. But 40 degrees is being taken up by the other side of this angle. So if we take this quadrant, we take 90 minus 40, that equals 50. So this right here is 50 degrees. From this point to this point, it's 50 degrees. But now we also need to include this right here. So we have to add this 90 degrees. So 50 plus that 90 is equal to 140 degrees. Oh no, off camera I am. Okay, so 140 degrees is from here to here. Now it says 40. I know it's very confusing. You don't add 100 or anything. No, that's not how you do it. That's just how it came out to. So let's do another problem. So we have our plane like this. Let's say we have a string coming from here, and then another string going like this. And we know that the angle right here, so let's say that's 5 degrees. And then let's say they tell us this angle to be 45 degrees. And now when we run our calculations, we need to know the angle from this x right here all the way over to this little line right here. So we're going to be measuring all of that, whatever angle that is. So we can get a quick head start right here. This to this is 180. A straight line, if you're going to measure the angle, that's 180 degrees. So we can start with 180. Now we need to add something to that. And so let's see, we know that this is 90 degrees. So we can take 90 minus 45, and then we're going to add that to 180. So before we do that, we take 90 for this quadrant right here, minus this angle, 45 degrees, and that equals 45 degrees. Now, we take our 180 for the straight line, and then we add this 45 degrees, and that comes out to be 225 degrees. So, from this x line right here, all the way over to this angle right here, this line, or string or whatever it is, it's 225 degrees. And then when we find our x and y components, for the tensions, we would say sine of 225 degrees or cosine of 225 degrees, just depending on what we're finding. Make it easy, 45. No. I wrote 225 degrees down here, but you can't see that. So that's essentially it. Yeah, let me know if you have any more questions.